Carl.
Hello, I'm Shallow.
Hi, I'm Yusuf, and we are Team Las Vegas.
This is our city. It's commonly known as Sin City. It's a city that's a mecca for gambling and for partying. But our city is not one-dimensional. It's a diverse city. It's a rapidly growing city, and it's a city that's constantly reinventing itself. Our city is known globally for its hospitality, and we believe that that hospitality should not only extend to the tourists that visit our city, but also to the residents that live there. Our university advocates the power of design and innovation to change lives. And using these instilled values, our team was directed to look at the Solar Decathlon not only as the opportunity to address environmental impact and energy concerns, but also as a way to serve the at-risk members of our community. The war in the Middle East is the longest running war in US history, and 1/3 of these service members return home with combat-induced disabilities. The trauma doesn't stop when they return home. They then face years of rehabilitation, or these disabilities can actually be the root problem for many larger problems, such as homelessness, substance abuse, incarceration, and even suicide. These men and women have chosen to serve their country, and we believe that it is our responsibility to serve them. We set out to address these changes faced by these returning veterans and help them transition into their new normal. Our home becomes a place for rehabilitation. Design is driven by the needs of veterans suffering PTSD and loss of limb. Incorporating environmental technology and renewable energy allows us to not only create a resilient, sustainable, net zero home, but also one that foregrounds the health and comfort of disabled veterans. Our design encompasses 5 key components that address these specific needs. Prospect and Refuge allows residents to both feel protected from and connected to their community and environment through appealing to the primitive desire to survey one's surroundings and the ability to retreat into a safe space. Incorporating biophilia has been proven in multiple studies to reduce stress, to lower anxiety and anger levels, and to even reduce the sensation of pain. Clear circulation, injury mitigation, and voice controls have ensured that each user can experience full enjoyment of their home. Sudden, sharp noises are dampened through insulation and layout, and ambient noise is introduced to help prevent triggering PTSD and to alleviate the effects of tinnitus. Many returning veterans experience night terrors and insomnia. By introducing natural light, specifically morning light, into the bedroom, we're able to reset circadian rhythms and help reduce sleep disorders. All these components work to address the specific needs of disabled veterans and to increase the viability of our design to this client.
With high rates of homelessness among veterans in Las Vegas and nationally, we chose to design the home specifically for them. It's designed for them to habilitate and establish a new normal. To respond to the PTSD trigger of noise, we've made sure our wall assembly has a sufficient STC rating, and we're also providing ambient auditory stimulation with plants. For veterans with amputations, we've minimized task distances throughout the home, and we have designed clear wide circulation spaces. We are confident that our home will attract occupants, contractors, and fabricators because this net zero home features modern comforts, automation, and it's unlike anything currently available in our city. Furthermore, occupants can count on a $0 annual energy bill. This results in a savings of about $2,000 a year in Las Vegas, and that number and there's even more potential for energy savings if they're using an electric car. To keep costs low, our materials, fixtures, equipment, and systems were all carefully selected and designed to balance initial cost as well as performance. We're using a steel space frame structural system that allows us to easily transport the home, but it also ensures that it will last a long time. This structural system was designed by one of our industry partners, Ahern Extreme Manufacturing. They are an innovative and locally started company that produces heavy equipment and modular buildings. These buildings are produced inside in a factory. This allows them to get the best results for the least amount of money by decreasing construction time, allowing less site disruption, increasing quality control, providing more safety for the workers, as well as having access to special equipment and being able to keep materials protected. For us, this is a community project. We're grateful for the knowledge and the support from our local partners, such as Commercial Roofers Incorporated. They're one of the largest roofing companies in Las Vegas, and they've supported our team on every single design build project that our university has ever done. In addition, we've partnered with Solar for our PV panels, and Nevada Energy has been integral in our fundraising efforts. In addition, we're also focusing on traditional and non-traditional fundraising efforts. And besides engaging our community, we've also engaged the entire university. Our team is an interdisciplinary one of 12 departments composed of students, faculty, and administrators. Our team structure was developed for efficiency, where each department has clearly defined roles and responsibilities, but everybody's encouraged to know all aspects of the project so we can come together and foster co-learning and innovation, and more importantly, to put together the best design that we possibly can.
Our design was inspired by vernacular housing in similar desert climates, such as Mexico and Syria. By reimagining the traditional courtyard house, we were able to design a comfortable home for the user while fostering a strong indoor-outdoor relationship that's conducive to the healing needs for disabled veterans. By utilizing screening and solar orientation, we were able to maximize natural daylighting throughout the home while still minimizing the heat gain in our hot desert environment.
Las Vegas is in the hot, arid Mojave Desert. Extreme temperature swings are expected. Limited rainfall and increasing water scarcity are some of the problems we're faced with. This lack of rain can lead to wildfires. Because of our local climate, our systems are simple, reliable, and redundant. This ensures continuity if anything malfunctions or breaks. To preserve our most valuable resource, water, we're conserving it and we're reusing it. In case of wildfires, we've installed sprinkler systems inside and a fire-resistant cladding outside. We want to use this project as a way to spread awareness of how to deal with these issues. Our communication strategy for the Solar Decathalon aligns with our university's goal of remaining a top-tier national public research institution in research, education, and community impact. We have and we will continue to use this project as an opportunity to enhance the image of the city of Las Vegas, not just as the entertainment capital, but as a sustainable desert community. We actually enjoy living in the desert, and we hope that our project will become precedent for cohabitating with our sometimes harsh but beautiful land, specifically with regards to energy use and its production.
To achieve a net zero home or a low home energy rating of -37, each design component and appliance to be used in the systems of the home was evaluated. For heating and cooling, energy requirements were minimized with the selection of insulation materials in the roof, wall, and floor. Optimal thermal performance was achieved with the R values of R30 for the walls, R40 for the floors, and R60 for the roof. Passive systems such as daylighting and cross ventilation will be used before active systems. The active solar thermal system will offset the energy needed for domestic hot water production and home heating. For electrical performance and consumption, energy efficient lighting and Energy Star appliances were selected. The home will also have a roof mounted photovoltaic system. that will power the home during the day and charge the batteries for night operation. The annual energy production from this PV is 12,219 kilowatt hours. The annual energy consumption of the home is 6,444 kilowatt hours. Without the PV, the HERS score would be 48. Now the home will have 2 batteries for backup power and peak power reduction. They will be utilized as storage for the photovoltaic system during the day and then power the home for night during periods of low solar radiation and grid isolation periods such as power outages. Now during this isolation from the grid, the photovoltaic system will recharge the batteries in an islanding mode and thus allow for the operation of critical load of up to 3 days. Without the, to reduce the demand on the batteries, the home automation system will use control receptacles and control modules to shed or share loads. An example of this is the cycling of lights. Instead of using all the lights at once, some lights can be turned off as others are turned off in different parts of the home, alternate operation, and thus allow to reduce electrical load. Temperatures may also be set back to reduce electrical load, and the home automation system can also advise the occupants of the need to reduce electrical load. Thank you.
Lighting appliances will be selected for energy efficiency and performance. The appliances will be ENERGY STAR rated and selected to perform as needed, but also complement the design of the home. Larger hot water draws are located adjacent to the solar thermal storage and with relatively short and well-insulated piping. An energy-efficient circulator pump will be used for the kitchen sink to circulate hot water to the kitchen and back to the solar thermal storage. This pump will be controlled by water temperature and also cycled by the home automation system during times of hot water demand. The home will have an electric vehicle charging station located on the outside of the mechanical room. This location shortens the electrical run needed for the relatively large energy use. The charger can be cycled off for electrical load reduction for demand response or load shedding. The home will use efficient LED lighting in every room to maintain or exceed required light levels. The lighting will be controlled by the home automation system, which will increase the intensity to maintain constant light during bright light conditions. The automation system will allow the programming of lights for themes such as for movie night and also activate on a schedule.
With this design, we are able to utilize Extreme Cube's space frame to offer a solid structure as well as have that simplicity when it comes to transporting the home. For us, we are using well-insulated wall, roofs, and floor structures utilizing advanced framing techniques as well as energy-efficient windows and doors. For our space conditioning, we are using 2 mini-split heat pumps that are highly efficient that are positioned to condition the 2 main zones of the home while also being able to condition the whole home individually, while also being able to quietly provide cooling, heating, and even dehumidification for the house. For the humidification, we are passively supplying it through the plant wall feature, as well as having, as well as using induced humidification in the fresh air system. For the fresh air, for the domestic water system, we've integrated both the fire protection system with a cold water system to be able to have a non-stagnating system overall. And for the hot water, we are placing most of the demands right by the solar thermal system to be able to demand that hot water as efficiently as possible while also using a recirculation pump to supply that based upon demand. And finally, we are collecting rainwater and filtering gray water to be able to irrigate the plants all across the home. For comfort and environmental quality, we're using again 2 ductless mini split heat pumps with a 30.5 C rating. Our fresh air PCM phase change material system filters outdoor air using pleated carbon and HEPA filters to remove any pollen, dust, or odors. And this also recovers energy using exhausted fans from that suck kind of the laden loads from across the house. And to reduce noise overall, the mechanical room will be isolated by insulated walls as well as separated from the bedroom using the bathroom. And the quiet outdoor units are rubber isolated to even further reduce the noise. And for all those systems, they have interchangeable components that are used to simplify the systems even further and even limit the amount of spares needed by the homeowner. Finally, for innovation, this year UNLV is offering 3 new innovation parts in this house. The first being the adjustable evacuated tube collector, which can recess completely vertically into the wall for transportation or even protection during extreme storms. The adjustable angle can also offer optimization to collection for various location, for seasonal performance, or even optimized performance based upon the hot water demand that is needed. Secondly, our phase change material, Fresh Air Plenum. As mentioned, this system offers filtering of the fresh air incoming, as well as recovering energy from exhausted air, utilizing an encapsulated phase change material located in the exhaust stream of an indirect heat exchanger. The phase change material heats or even cools the incoming fresh air to a 78 degrees Fahrenheit, as well as it is regenerated by the exhaust air or cooler evening air during cooling seasons or warmer winter days. Finally, for our compact solar thermal system, this system combines major components of the solar thermal system, such as the pumps, the mixing valves, into one compact unit that can be easily mounted on a wall, or in our case, on the hot water storage tank. This is just to simplify the amount of plumbing needed for such system. We also believe that this has a very good potential for marketability as like an easy installed off-of-the-shelf product that you can just plug into your house, and that would even limit and eliminate the complexity of putting such sort of system together.
Our team is focused on leveraging our diverse backgrounds, talents, and community network to build a more resilient, sustainable, and equitable future for our community. Thank you for your time, and we'd like to open up for questions.
Okay, so great presentation, well rehearsed, well drawn. Thank you for all the work you put in. I wanted to ask a couple of questions about, well, I have a couple questions. I'll just start with the project where it will be built in your home community. Do you have an identified site? And then as a follow-up to that, do you have control or ownership of that site?
We do have an identified site. I'm not 100% sure it's been solidified, but I believe that it's going to be on campus. No?
It's at Gayfern. We have a contract with the building, their modular building company firm, and so we'll be building in their yard outside. So they will be assisting us in that.
For construction, and then will it be installed there for
like permanent?
Is there a permanent site identified, or for the
Not
or
yet.
even for the testing period, will it be in that site?
Oh, yes, it will be there for testing.
For testing, okay. And then can I ask another question related to the kind of feasibility of the construction part? Can you talk a little bit about how this structure, so I understand the steel space frame, and from what I understand from your drawings, the wood structure is sort of co-planar with the steel structure. Your joists are actually in the same plane as the steel. And so the steel is effectively wrapped by wood, both or the metal cladding. So how is the house intended to be moved? Will it be lifted by crane, or does it have wheels on a chassis, or how does that work?
You want to show the slide, the engineering first slide? So those things on the right are that's their structural system, and you'll see that there's these 2 little holes right here. This is actually a forklift holes. So these are more like room modules, whereas our system is going to be like the whole house. It's going to be one structural system. So it'll have forklift holes in there. And then, yeah, so we're using a 2x4 or 2x6 stud inside of that plane, as well as 2x12s in the floor and the ceiling.
So that steel is then exposed for the
No, so actually the steel is, so the it will, so for actually like moving it, we will have the ability to remove a, like a piece. It's gonna be flashed, but we'll have the ability to move it via, it's actually gonna take a couple of forklifts, but, so working in unison. But it is all, we've really worked hard with extreme cubes to combat thermal bridging, so to prevent that from reducing any, or from heat gain in the actual home.
So one question on the performance of the air quality system, what's the upscalability of that? If it was required for a larger house, what's the kind of extreme nature of that?
Well, probably in that terms, we'll probably have a bigger system and probably have like a couple of them in a sense. Because obviously those, over here, as you can see, like those are the filters. In our house, we basically take out fresh air, supply it in there, but that fresh air is like kind of warm, especially when you want to cool the house. It will go through there. So if you want bigger performance, better performance, you'll probably want to have more of those located all around that bigger infrastructure, or even maybe have a bigger one. But it's like a balancing act depending on how big of that overall building would be, depending on how you want to optimize that as well.
I was curious. I was hoping you could talk a little bit more about your solar calculations.
Okay.
It seemed like you had a lot of PV compared to your
we do
annual
have excess
consumption.
PV.
And I was wondering how you calculated that
How I calculated
and
it.
why.
Okay. This annual energy production.
Mm-hmm.
Okay, so we broke down each system and what are the appliances or components that are being used, their electrical use, their energy use, multiply that by the usage, so the hours per week, times the power rating of each appliance or component, and then you get and then you multiply it by how many weeks in a year, 52, and then you add it all up, so that's the annual, that would be the annual for one, so then you add it to the rest of the components, their annuals, to get the annual energy production.